Hello students, welcome back. The question is from GATE 2006 exam. It's for 2 marks. Before discussing its solution, I like to discuss about two topics. First one is duty cycle and second one is phase shift. Okay. What is duty cycle of a signal or a clock? Just take two positive edges. So this one is a rising edge, this one is a rising edge. You can take any two edges. Let's say this one and this one. Okay. Between two positive edges of clock, for how much percent is the value equal to 1? That is the duty cycle. You can see for half of the time clock is high, for half of the time clock is low. Okay, so it's half of, that means 50%. Duty cycle is 50% for this one. What is duty cycle for this signal? Let's calculate it. Between two positive edges, say this one is a rising edge and this one is a rising edge. Okay, so between these two edges, for half of the time value is 1, for half of the time value is 0. That means it also has a duty cycle of 50%. In this question, they are saying clock has duty cycle of 50%. That means there's nothing new. It is the normal clock signal that we use by default. Okay. Now let's take one more example. Such a clock signal will have a duty cycle of 10%. Okay, say this is the total time period. Say this much is 10% of this total. So clock remains high for 10% of the time and duty cycle will hence be 10%. Okay. Now let me discuss about phase shift. What is phase shift? In class 11th, you studied the topic of waves and oscillations in physics. Okay. This one is just the basics of that topic. Suppose this is some wave. I want to phase shift it by 90 degree. I'll start the new wave from here. This is how we phase shift by 90 degree. Okay, if you want to phase shift by 180 degree, I'll start the new wave from here, okay, from this point. So this one is phase shift of 180 degree. You can see when we phase shift by 180 degree, the value is exactly opposite. If you have the amplitude is equal to maximum value, in this signal, at that same point of time, amplitude will be minimum. Okay, it is maximum here, it is minimum here. Now let's apply all of these things to square waves. Okay. Say this is a square wave. I want to phase shift it by 180 degree. So at this point, it has minimum value. Okay, that means 0. In the new wave, it has to have the value equal to 1. So we have a 0 here, this wave has 1 here. Then next one 0, then 1, then 0. So this is phase shift of 180 degree. See, it is 0, it is 1. Now this one is 1, but this is 0. This is 0, this is 1. Okay, so completely opposite. Now let's discuss this question. You are given a free running clock with a duty cycle of 50% and digital waveform f which changes only at negative edge of clock. Which one of the following circuits using clocked D flip-flops will delay the phase of f by 180 degree? Okay, so they are saying the input f changes on negative edge of clock. This is a rising or positive edge, then negative, then positive, then negative, and so on. So initially you can take value of f anything. I'm taking it to be 1 initially. Upon seeing a negative edge, the value changes. That means it becomes 0. Upon seeing next negative edge, it becomes 1. Then 0, then 1, then 0, so on. Okay, upon negative edge, just complement the value of f. Such a signal is given in the input. Okay, now we need to determine which of the circuits will phase shift F by 180 degree. Let's start with option A. So both of the flip-flops are clocked flip-flops. Okay. This one will react when a negative clock is applied. Okay, on negative edge. Because by default we assume them to be positive edge triggered. But using a NOT gate here will make it react only when a negative edge of clock is applied, because reversing it will just give a positive edge to this flip-flop. Okay, this is a normal flip-flop only. It will react on positive edge because no NOT gate is used for providing a clock. Okay, that means whatever is the value of F, its complement will be this output Q. If F is 0, Q, I'm calling it flip-flop 1. So Q1 will be 1 because we are using a NOT gate here. Upon seeing a negative edge, okay, this will happen upon a negative edge. And Q1 complement will be 0, okay, because whatever is this value, this will be its complement. See, what is happening is we are reversing F or complementing F, and that is given as output Q. Again we are complementing it for calculating output Q complement. So F is reversed twice. That means F will be left as it is. Okay. Now let's start our question. In option A, you can see this flip-flop will react on a negative edge. This is the first negative edge. At this time, value of F is 1. You can see for this entire time, from here to here, F is high. So F is 1 means Q bar will also be 1. Okay. So I'm writing Q bar is equal to 1. Or let's call it Q1 complement. It is Q1 for flip-flop 1 and its complement is 1 during this negative edge of clock. Okay. But I am not drawing any waveform for this because this is an intermediate output. This is the final output. We'll worry only about this output. Now this flip-flop will react on a positive edge. Let's see what happens in a positive edge. During this edge, whatever is the value of Q bar, that will be given as input D. During positive edge, this value will be transferred here. That means Q bar is the final output during a positive edge. Q bar is already calculated as 1. So during a positive edge, the final output will be 1. Okay. So I am drawing this signal. Now on negative edge, will this flip-flop react? No, it won't react. Only this one will react. Okay. Upon negative edge, whatever is F, that will be the new output Q bar. Okay. So this value, this one, it will be same as F. On a negative edge, F is 0. Okay. So upon a positive edge. Okay. Sorry, again, it is negative edge. On negative edge, that means this one, Q1 bar will be 0. That is same as F. For this entire time, F is 0. Okay, so Q1 bar will be 0. Now, upon negative edge, this 0 will be given as the output. Okay. That means at this point, on a positive edge, the output will be 0. Okay. Until this point, it remains 1 only. Now it becomes 0. Okay. See, during negative edge, only Q1's value can change. This is Q1. Only this value can change because this is a negative triggered flip-flop. It reacts on a negative edge of clock. This one is a positive edge triggered flip-flop. It will change its value only during positive edges. So if this is a positive edge, whatever is value calculated here, that will remain as it is during negative edge and could possibly change upon a positive edge only. Okay. That means here also this value will remain as it is. If it is 0 here, it will remain 0 here because second flip-flop won't react on negative edge. Okay. second or the final flip-flop will only react here. But at this point of time, first flip-flop is going to react. Whatever is the value of f, that will be present in Q complement. Okay. So at negative edge, that means here, whatever is f is 1. Okay. So at this point, Q1 complement will be 1. Okay. This flip-flop will react to the input f and this will be made 1, Q complement. During next clock, that is the positive edge of clock, this flip-flop will copy this value and keep it as the new output. So the new output is this value only, like this. Okay. This final output won't change on a negative clock because this is a positive edge triggered flip-flop. So it will remain as it is until a positive edge. But during this negative edge, value of this Q will change or this Q complement will change. Let us calculate what is Q1 complement here. It will be same as F. Okay. So F is 0. During this positive edge of clock, this 0 will be the final output. So it will be like this. And during negative edge, final output won't change. So it will remain as it is. Okay. So you can see this is not phase shift by 180 degree. We want a phase shift by 180 degree. Here value is 0. Here value is 1. It could be phase shift by 180 degree. But what about this? For this time, its value is 1. Its value is also 1. This is high. This one is also high. Okay. So this is not the correct option. Option A is rejected. Okay. Let's see what is option B saying. So we will just solve this option quickly. See, whatever is the value of f, its complement will be the output Q. Okay, so f complement is given as output on a positive edge of clock. Okay, so this change takes place on a positive edge. Due to this NOT gate, this flip-flop becomes a negative edge triggered and this value will be given as final output upon a negative edge. Okay. So upon a positive edge, just a second. This is the first positive edge. Okay. During this edge, F complement will be given as Q1. So F is 1, F complement is 0. Q1 will be 0 during this point of time. Okay. And during a negative edge, this 0 will be given as the final output. So during negative edge, final output is 0. Because this is negative edge triggered, it won't react on a positive clock. Now this is a positive clock. This flip-flop won't react. That means 0 will remain as it is until a negative clock because it is negative edge triggered. Let us see, this one will react on a positive clock. Let us see what will happen to this flip-flop. On a positive clock, Q1 will be complement of F because of this NOT gate. Let us see what is value of F during this positive clock. During this clock, F is 0, Q1 will become 1. Okay. And during this negative clock, this value, okay, whatever is this will be shifted in the output. Okay. So Q1 is now 1. This will be shifted in the output. And this output will remain as it is until the next negative clock. Okay. You can see this is the exact same way. When value is 0, this value is also 0. When value is 1, this value is also 1. So B part cannot be our answer. At 0, we require 1. Okay. So let's see option C now. See, option C is whatever is F will be same as Q or Q1, 1 for this first flip-flop on a positive clock. Okay. And that exact same value, that means whatever was F will be transferred upon next negative clock, okay, before seeing a positive clock, that means you apply some value of f. Upon positive clock that will reach here, upon negative clock that will reach in the output, okay. So 1 is applied here, f is equal to 1 at this point of time. On a positive clock, that means here the value will reach to q, okay. So q is 1 and upon a negative clock the value will reach here, okay. So this one will reach here. At this point, final output is 1, okay. Now, at a positive edge, the final output won't change because this is a negative edge triggered flip-flop, okay. It will react only on negative edge of clock. So at this point, just keep this output as it is. But at this point, here on a positive edge, this flip-flop will react. Whatever is the value of f will be shifted here, okay. So let us see what is f. During this point of time, f is 0, okay. That means 0 is shifted here, okay. And upon a negative edge, that 0, this 0 is shifted here, okay. So upon a negative edge, that means here, the final output becomes 0. Like this, okay. Now during this positive edge, only this flip-flop is going to react, this won't react, okay. This is going to react, means value of f is shifted here. So during this point of time, f is high, so 1 is shifted here and this will not react. That means final output will not change because final flip-flop or second flip-flop is not reacting. Now during this point of time, this one will be shifted here, okay. This one is shifted here, that means output becomes high, like this. Here it will not change till here. You can see this is actually phase shift of 180 degree. If value of f is low, output is high. If f is high, output is low. If f is low, output is high, and so on. So your answer to this question is option C, okay. Now I'd like to discuss a point about this option C. See, this f takes one positive and one negative edge to reach here. That is phase shift by 180 degree. So let me just show you from this diagram. See, upon positive edge, this flip-flop is going to copy f. So take any positive edge. Let us suppose this one. Okay. Upon this positive edge, first flip-flop is going to copy the value of f. That means 1. So this flip-flop copies 1. Upon next negative edge, this flip-flop is going to copy this value, okay. So upon next negative edge, that means this point, the output will be this, that means 1, okay. So here the output will be 1, like this. For 0, the output is 1, okay. Let us calculate what will be output here. For that, we need to consider this positive edge, okay. During this positive edge, first flip-flop is going to copy f. So during this point of time, first flip-flop copies f. F is 0, okay. See, f is low here. So this copies f means output becomes 0. During next negative edge, this flip-flop is going to copy 0, okay. So that means during this point of time, the flip-flop copies 0. That means final output becomes 0, okay. And it remains 0 during a positive edge because this one will not react to a positive edge. Here the value is 0. That means like this, okay. Sorry, here the value is 1. It's not 0. So that's all about this question. I'll recommend you analyze this option also, okay.